Welcome to Green Numbers Data Tutorials. In this video, I'm going to show you how to use joins in SQL to join datasets. Joins are similar to a merge in the data step, if that's more familiar to you. Because SQL comes from the relational database world, the join feature is really useful and intuitive. I'm going to go through a few examples, starting with a comparison to this data step merge, and then move on to more complex joins. And for our examples, we're mostly going to work with this addresses data set that I downloaded. And you can see that it has some name information, some address information, address, city, county, state, zip code, and some other things. We're mostly going to focus on the zip code for the first few examples. And what we're going to do first is add longitude and latitude of the zip code to this data set. So we're going to put it at the end over here. And the way that we're going to add longitude and latitude to our addresses data set is we're going to join the addresses data set to the SAS help.zipcode data set. And in here you can see that in addition to zip code, there's this X and this Y field. This is longitude, this is latitude. And to start out, we're going to do a data step merge. So to do a merge, you first have to sort both data sets. So first we're going to sort addresses by zip code. Then we're going to sort SAS help.zipcode by zip. This is also zip code. They have different names, but they're the same zip information. And because SAS help.zipcode can't be sorted, it's a read-only file, or I'm outputting it to a work.zipcode data set. And then, as we typically do in a merge, we merge the two different data sets. So first we have addresses, and we're going to merge it with zip code. We're going to create a new data set called addresses XY, and we're going to merge on the zip field. And in order to merge in the data step, we need to rename zip code to zip, or zip to zip code, because this by statement has to use the same name that we're going to merge on. And for this, I'm also using a keep statement on the zip code data set because some columns overlap and have different data types. And for comparison, we have this SQL code below that creates the same output that our data set merge does above. So what we have, we're creating a table named addresses XY SQL from the addresses data set. And then we're doing a full outer join to zip code. And I'll explain full outer join in a moment. But the intent is to mimic using SQL what we're doing up here in the data step. And we're joining on zip code from the addresses data set and zip from the zip code data set. And so first you might notice that for the SQL, we don't need to sort first. That's not something that's required for the join in the SQL. And also we don't need to rename the variable that we're going to join on. We can keep the names that come with the data sets. So in our select statement, we're going to keep everything, so that's this asterisk, from our addresses data set, and we're going to grab the X and the Y columns from our zip code data set. Another advantage with the SQL join is that we can reorder our columns any way we like. For example, if I want to put the X and the Y in the front, all I have to do is move them to the front of the select statement. So let's go ahead and run all this code. So first we'll look at the log. And you can see that both data sets have 41,190 rows and 14 columns. And then if we go to our output, you can see that there's no data except for zip and X and Y for the data set until we get to, I believe, the fourth page. Now we run into some down here. And that's because the default for merge is a full outer join. It keeps everything from data set A, so that's the address data set, and it keeps everything from data set B. That's our zip code data set. And this can be useful, but this is not what we want for this example. What we want is a left join, keeping all rows from data set A and only rows from dataset B that match A. So this is what we're going to do in the next example. So this is just like our code above, but in the data step down here, I added this n equals A, which assigns A to our addresses data set. And then we have this if statement down here, if A, meaning that if the records appear in this addresses data set, then output to addresses XY. And then for comparison, in our SQL code, I changed the full outer join to a left join. So let's go ahead and run this code. So if we look at our log, we see that both data sets have 497 rows and 14 columns. So this is a good place to watch for duplicates. If more than 497 rows, which is the number of rows in the addresses data set, then it's likely that the zip code data set includes multiple rows with the same zip code. Now, if we go to our output data, we see that now there are no missing values in these fields. Also in this code, you might notice that now, instead of using addresses in front of the asterisk and zip code in front of the X and the Y, I've created an alias. So addresses as A, zip code as B. Now I can just put an A in front of the asterisk for all fields in the addresses data set, and a B in front of X and Y, meaning the X and Y come from zip code. You can also control the output by using a where clause. So this top block right here doesn't contain a where clause. It's the same left join that we ran above. But this bottom block now has this where clause right here, where b.zip is null. This tells SAS to only include rows from addresses that did not match a zip code from the zip code data set. So let's run this code and look at the log. So you can see that the data set with the where clause only has one row. And if we look at our output and look at the zip code, we see 10048. And that X and Y are blank. This tells us that the zip code is not valid, or a zip code data set is incomplete. So let's look at our zip code data set. And we see that 10048 is not here. I also wanted to point out in our code that you can include more than one SQL block in our PROC SQL statement. All we need is the PROC SQL, as many blocks of SQL code as we want to run, and then a quit statement at the end. So a right join is the opposite of a left join. And in example 4, we have our left join code, but I also added a right join code to the same code block. So you can see the right join here. And I also swapped the addresses from the from clause to the join clause, and I changed the zip code from the join clause to the from clause. And I also made sure to keep my aliases consistent. And these blocks should generate the same data set. So let's run this and look at the log. And you can see that both data sets have 497 rows and 14 columns. And if we look at our output, we can see that our left join, which is this, is the same as our right join, which is this. So here we're back at our diagram. We're going to look at inner joins now. An inner join outputs only rows that match both data sets. So let's go back to our code. Example 5. So here we have our left join again, and both of these blocks are the same, except this one is an inner join instead of a left join. So let's run this and look at our log again here. And we can see that our left join has 497 rows and 14 columns, and our inner join has 496 rows and 14 columns. So remember, in a previous example, we saw that one record in the addresses data set didn't match a zip code in the zip code data set. And that's why there's one fewer record in the inner join. So I also wanted to show that you can join on multiple data sets, which is what we do here in example 6. In this example, in addition to joining on zip code to get the longitude and the latitude, I'm joining on a county codes data set that I'll show you in a moment to get the county code. And this is the county FIPS code, if you're familiar with that. So to do that, I added another left join with an on clause that matches on county name and state code. And the reason you need to match on both of these fields is that if we go to our county codes data set, you can see that we have the state code here and the county name here and the county code. But if I sort by county name, you can see that the same county name is used in multiple states. So to join on county name, I need to match on county name and on state code. So let's go back and run our code. Take a look at our log. As we expected, we have 497 rows and now 15 columns. If we go to our output and go to the end, we see that in addition to longitude and latitude, we now have the county code column. The one last thing I wanted to show you in example 7, one example the dataset merge has is that it can easily output to multiple data sets. So you can see that I added an n equals a for addresses and an n equals b for zip code. And then I added these if-else-if statements below. So if a and b, meaning that if a row and addresses matched a row and zip code, then output to AB. Else if the row only matches addresses in A, meaning it doesn't match any zip code in the zip code data set, then output to A only. And then if there was a row and zip code that didn't match any of the zip codes in the addresses data set, then output to B only. So let's go ahead and run this code. Look at our log, and we can see that AB has 496 observations. A only has 1. This is that one record that had the zip code that didn't match any of the zip codes in the zip code data set. And then all those zip codes that were in our zip code data set that didn't match any of our addresses, which are considerable, 40,693 were output to B only. And outputting all the data sometimes gives you more information to validate your output. And that's it for this video. In the next video, we'll get into summarizing data with SQL, and later we'll look at creating macro variables with SQL. If you found this video useful, please give it a thumbs up and be sure to subscribe to get more content. Thanks for watching.